If you look at the title here, the title is Real Numbers, which must seem a little bit strange. Basically, a real number is any number you might have heard of at any time in the past. There are other numbers, other types of numbers that we kind of invent, or mathematicians invent later on. You might possibly have heard of complex numbers or imaginary numbers, but almost everything that you might encounter is a real number. One particular type of real number are natural numbers, and these are the numbers that people began with. People began counting 1, 2, 3, 4, 3 horses, 4 sheep, in order to keep count of their belongings. Unfortunately, there's a little bit of a problem with the names of these things. Some people call 1, 2, 3, 4 natural numbers. Some people say they're whole numbers. Some people say that 0, 1, 2, 3, 4 make the whole numbers. But we will just call them natural numbers. And then people thought about negative numbers. They imagined, for example, cold temperatures that were below 0, say -1 degree, -2 degrees, and so on. So all these numbers here we call integers. Right? Integers going up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but also going down -1, -2, -3, -4. People also quite early on began to think of rational numbers because they were dividing up fields, for example. And if they had a field that was of size 1 acre and they divided it by 2, perhaps there were 2 children in a family, then each person would have half an acre each. And so all these things here, rational numbers, in each case they can be written as an integer divided by another integer. 1 divided by 2, 4 divided by 3, 7 is 7 over 1, -3 over 5, that's -3 over 5. Always an integer divided by another integer. And then irrationals, that's everything that isn't a rational number. So there is a proof somewhere, it's quite a nice proof, that the square root of 2 is not rational. Likewise, negative, the square root of 3 is not rational. Pi, that number that starts 3.14159, it is also an irrational number. There's a number e, which you might have seen before. We use it in exponential functions. That it's roughly 2.718, but it again is an irrational number. We can't write them as an integer over an integer. And then all the real numbers, that's all of these numbers here, make the real numbers. Now there are certain types of decimal numbers, like this one here, 0.33333333, which are called repeating decimals. And the question arises, are these numbers rational or are they irrational? Can we write them as an integer over another integer? And we can look at that, we can try and solve that question here. We let x be whatever the number is, and then in this example here we can multiply x by 10, which means we have to multiply the 0.333 by 10, and if we do that we'll get 10x equals 3.3333. You'll notice then that 10x is equal to 3 plus 0.333, which is the same as 3 plus x. So in other words, 10x is equal to 3 plus x. We can rearrange that. Just, for example, take the x over to the other side, so it's 10x minus x, giving us 9x. 9x equals 3. Therefore, x equals 3 over 9 or 1 over 3. So we've done it for this number here. 0.333 is 1/3, 1 over 3. So we know that this number is a rational number. And actually, it doesn't matter what repeating decimal you have. For example, if it's 1.232323, it's always going to be a rational number. It's always possible to write it as an integer over an integer. Start by letting x be equal to the number. Now, since we've got a 2323 pattern, we don't multiply by 10 this time. What we actually have to do is to multiply by 100. If it were every 3 that we're repeating, you'd have to multiply by 1,000. Okay, so we've got 100x equals 123.232323, and x equals 1.232323. What you can then do is subtract 100x minus x. We're subtracting the left-hand sides of these equations. But also then, you can subtract the right-hand sides. 123.2323 minus 1.2323, giving us 122. From then, what we should be able to see is 99x is equal to 122. Therefore, x is equal to 122 over 99. Now, on this second page, your job is to say all the different types of number from the first page that these numbers belong to. So just to start you off, at that 6 there, well, that's 6. Okay, it's a natural number. It's in one of those ones that goes 1, 2, 3, 4, 5, 6. Okay, that's 6. Is it rational? You can write it as 6 over 1. Is there anything else that it might be? You could say that it's also real. It's also an integer because it's in the set of integers also. So it's all of these things here. Just spend maybe 5 minutes now writing down what you think are all the descriptions, all the different types of numbers that all the numbers on this list are. Okay, I hope you've done that. We'll just go through them very, very quickly. Negative 68, okay, it's not natural, because natural is only positive numbers, but it's everything else. Integer, rational, real. 12.7, is it possible to write that as an integer divided by an integer? Yes, 127 over 10 would work. Okay, so it's rational and it's real. 0.66686, it's a recurring decimal, therefore it's rational, it's real. Square root of 25. Often the square roots are irrational, but if the square root happens to be an integer or happens to be a fraction, then you do have something that's rational, and in this case also an integer. The next one, okay, it's an integer divided by an integer, so obviously it's rational, but also, if you do the calculation, it's actually a whole number or natural number. 2 pi, anything times pi, apart from 0, anything times pi gives you an irrational number. Negative the square root of 23, well, the square root of 23 is not rational, it's not a nice number. So all we've got here is irrational. 7.23232323, that again is a recurring decimal, so it's going to be rational and real. And then this last one, square root of 5 divided by 3, the top is not an integer, so it's not a rational number. It's not possible to write that as an integer divided by an integer. Okay, remember that all natural numbers are integers. All integers are rational numbers, and all rational numbers and irrational numbers are real numbers. Now, that means that we can draw a Venn diagram illustrating that, illustrating the fact that natural numbers are inside the integers, and integers are inside the rational numbers. That drawing is right here. We have the natural numbers here, right? 1, 2, 3, 4 are inside the integers, because the integers also include -1, -2, -3, and those integers are inside the rational numbers, because the rational numbers also contain 2/3, 1/2, and so on. And the rational numbers come inside the real numbers. The real numbers are all the different numbers. And you'll see over here the irrational numbers, that's everything that's not rational, but is still within this set of real numbers.